Let's learn about molar mass. First, I'll define molar mass, then give examples of small molecules like methane and glycine. Then give one example of the ionic compound calcium carbonate. Molar mass is simply the mass of 1 mole of compound. To find molar mass, we first need to identify the moles of element present per mole of compound. Let's use methane as an example. The molecular formula is CH4. Each molecule has 1 carbon atom and 4 hydrogen atoms. The element-molecule ratios are 1:1 for carbon and 4:1 for hydrogen. But we can also think of this in terms of moles. Think of 1 mole of methane molecules. There would be 1 mole of carbon and 4 moles of hydrogen. To find molar mass, we need the atomic weights from the periodic table. Obtain the atomic weights from the periodic table and multiply the mass of carbon by 1 and the mass of hydrogen by 4. The sum is the molar mass. 16.05 grams of methane per mole of methane. This is sometimes called the molecular weight for molecules. Now, let's look at a larger molecule, the amino acid glycine. Amino acids are small molecules which make up proteins. Glycine is the simplest of the amino acids. Its molecular formula is NH5C2O2. I'll first identify the moles of element present per mole of glycine, which are 1 mole of nitrogen, 5 moles of hydrogen, 2 moles of carbon, and 2 moles of oxygen. Multiply each mass by the moles of element present to give the masses of each element. The sum is the molar mass, 75.08 grams per mole. Let's close with calcium carbonate. Calcium carbonate is an ionic compound, not a molecule. So we cannot use the term molecular weight. For ionic compounds, it's common to use the term formula unit, which refers to 1 particle for molar mass purposes. Again, I'll identify the elements present. In this case, there are ions present, but ions do not affect the atomic weights, so use the atomic weights from the periodic table. Sum the masses to give the molar mass for a formula unit of the ionic compound calcium carbonate, which is 100.09 grams per mole.